Hello friends, welcome to Optical Fiber Communication Numericals video. In this video, I'll talk about a few numericals which are important from the point of view of examination. So formula to remember are written on the right hand side. So the first formula that you need to remember is that of critical angle. I've represented it with phi c. It is sine inverse of n2 by n1, where n2 is the refractive index of cladding, n1 is the refractive index of core. Then we have the formula for numerical aperture in terms of refractive indices, and then we have the formula for numerical aperture in terms of delta n, which is the difference of n1 and n2, and then we have the formula in terms of delta, which is relative refractive index, which is n1 minus n2 upon n1. Then we have acceptance angle, which is theta a, sine inverse of numerical aperture. Very important formula for V number is 2 pi a by lambda into numerical aperture. You know this thing is numerical aperture. Then we have the M, which is number of modes, which is alpha upon alpha plus 2 into V square by 2. V is V number, and alpha for step index fiber is infinity, that of triangular profile is 1, and parabolic is 2. So we are going to use these formulas to solve these numericals. The first one is pretty simple, where the refractive index of core and cladding is given. We need to find out critical angle. Please understand, the critical angle is found at core and cladding interface. You can, if you wish to see the theory, you can refer my previous videos. And acceptance angle is formed at air and fiber interface. So let's see what's given in this. N1 is given, N2 is given, and the first thing that we can find out is the critical angle, which is sine inverse of N2 by N1. Pretty simple. So this will turn out to be 78.5, putting 1.47 here and 1.5 here. So I'm going to quickly go through the numerical aperture, which would be 1.5 square minus 1.47 square under root, and I'll write down the values here. Alright, and then you can find theta c, which is sine inverse of numerical aperture. Numerical aperture is found here, so sine inverse of 0.3 will be the answer. Alright, now let's get to the next question. In the next question, the relative refractive index, so the delta is given, which is I also mentioned it is n1 minus n2 upon n1. So this is given to be 1% or equivalent to 0.01. n1 is given to be 1.46. So if you wish to calculate numerical aperture, one formula is n1 into under root of 2 delta, and putting the values here, 1.46 into 2 into 0.01, I get 0.21. So this is numerical aperture, and once numerical aperture is found, we can easily find acceptance angle in air, but this is solid acceptance angle. Please understand, acceptance angle is theta a, which is sine inverse of numerical aperture. So this is going to be sine inverse of 0.21. So this will come out to be 12.12. But if you wish to convert it into solid, you know the formula. You can multiply it with pi and divide it by 180 degrees. So that is what it is, and from here we can find that this is 1 minus n2 by n1. So n2 by n1 will become 1 minus 0.01, which is 0.99. And why am I finding this? Because critical angle, which is phi c, this is equivalent to sine inverse of n2 by n1. So if I say this is sine inverse of 0.99, the angle, critical angle, will become 81 point something degrees. All right, so this was the first set of numericals, and now we have the next set of numericals, which are from B numbers and modes. We know that a graded index optical fiber has a parabolic. So the first key point is parabolic. We know for parabolic alpha is 2. The refractive index profile has a diameter of 50. So diameter is 50 micrometers. So A will be 25 micrometer. The fiber has a numerical aperture of 0.2. Estimated total number of guided modes. So we know that guided modes are alpha upon alpha plus 2 into v square by 2. So we need to find v first. So v is, so if you look, the formula is 2 pi by lambda n1 square minus n2 square, which is numerical aperture, by the way. So what I do here is this is 2 pi into a by lambda into numerical aperture. So I'm going to put the values 2 pi into 25 micrometer upon wavelength is 1 micrometer and numerical aperture is 0.2. So when you solve this, you'll get the values 0.2. Okay, so once you have this value of, you'll get the value 31.4. 0.2 is numerical aperture, by the way. And so once you have the value of v, you can substitute it here, and alpha is 2 upon 2 plus 2 and 31.4 square by 2. So you'll get 246.49, which is almost equivalent to 247 modes are possible in such a optical fiber. Alright, the next question is interesting. The multimode step index has a relative refractive index. Again, delta is given, which is n1 minus n2 upon n1, and the value of this is 0.01 again, because 1% is 0.01, eta 1 is 1.5. So whenever delta and eta 1 are given, you can directly find numerical aperture to be equivalent to 1.5 into under root of 2 into 0.01. So my numerical aperture will become 2121. The wavelength for this is 1.3 micrometer. Cool. So we can easily find v number, which is 2 pi by lambda into a into numerical aperture. Correct. So substituting the values, 2 into 3.14 upon 1.3 into 10 raised to the minus 6 into a is something that we need to find, the diameter, and for how many modes? 1100 modes. So let's calculate v. So this is going to be a, and numerical aperture is 0.2121. So this is step index. For step index, we know this is going to be v square by 2 m, and m is how much? 1100. So substitute 1100, and this is going to be 1 by 2 into v square is this much, 2 square into pi square into a square into 0.2121 square upon 1.3 into 10 raised to the power minus 6 square. Easy. So what we need to do is we need to find a when the modes are given, when the number of modes are given. So that's pretty easy. So a turns out to be 45.77 micrometer, but we are needed to find the diameter, so it is, diameter is twice of a, so this is going to be something 91.5 micrometer. So these are the 4 numericals that I wanted to target. These can be solved using these formulas. You could pause the video, note down the formulas, super important. And if you liked the video, give it a thumbs up. I'll see you around. Take care. Bye-bye.